set. Well, welcome everyone to the latest installment of our BART webinars, and thanks for joining. We're really excited. This time we're kind of showing some of the things that we're working on in terms of adding new features. We know that these days everyone is using Python for lots of different things, and we really want to strengthen the integration of BART with Python and make it more of a library that you can call. So that includes high-level calls, like calls to the command line tools, but we're also working on lower-level calls. So actually accessing the API through Python so that it could be used with things like NumPy and SciPy and other packages, just like any other module. So this is kind of a work in progress. I'm going to hand it off to Max, who will present the new interface for Python. He'll focus on the command line tools, where there's really kind of a one-to-one correspondence with the old command line tools. And then he'll talk a little bit about where the Python interface is going. And since it's a smaller crowd, we also are really interested in getting feedback about it, both BART in general, but also this Python interface and what you might think about what you would want. And if you're interested in really testing it out, we would really be interested to get your feedback. The format, though, for this webinar is going to be like the previous one. Max will give an introduction and then go through a demo exercise together, and then we'll do breakout rooms where there is an exercise that you fill in yourself, being led by one of us. So anything else before we get started and Max takes over?
Yeah, maybe just worth mentioning that the previous interface will still be supported, but all new developments will be implemented in the new interface. So just be aware of that when thinking about future development.
All right, sounds good. Okay, well, I'll hand it off to Max. Spotlight you.
Awesome.
Go ahead.
Thank you, John. Thank you, Mickey. Hello, everyone. My name is Max. I'm a fourth-year undergrad at UC Berkeley. Been working on this Python interface for a little while now. Very excited to show it to all of you. So a quick overview, we're going to have a high-level presentation first, talking about some of the goals for this project, what's currently available, and what we look to achieve in the future. Then we'll go into a quick demo of how to install the package, and then I'll show off some use cases before we get into the rest of the webinar.
All right.
That's it. Awesome.
Should be good now.
So with that, we're going to start with a quick overview presentation to set the scene for some of this work. Going to be sharing that right now. All right. Does this look all set to everybody?
It's not in full screen mode, though.
Oh, interesting. Let me try that again. Oh, there we go. All right. All right. So, as it stands, currently the BART toolkit is divided into high-level command line interface tools for computational MRI. That's what one can access when they interface with BART on the command line. And then within the code base, there are a series of high-performance, low-level libraries for doing things like various optimization, running various optimization algorithms, interfacing with multi-dimensional arrays, performing things like the fast Fourier transform and other useful reconstruction tools, all of which exist beneath the surface of the command line tools to make all of those run. So additionally, at the moment, there's an extensive network of scientific Python libraries, things that users might be familiar with, like NumPy, SciPy, SigPy for signal processing specific applications. And these are also very popular among users who might use BART for related tasks. So our goal with this project was to both make the existing BART Python interface more friendly to users who are familiar with these Python libraries, and also expand upon the interoperability of this existing network of scientific libraries with the BART tools to create a seamless ecosystem for many of our users working in Python. So a quick overview of some of those goals. The current Python interface, the new Python interface is more intuitive to users familiar with working in Python, be interacting with NumPy arrays seamlessly, working with functions and objects, the syntax that will remind users of NumPy, sklearn, so on and so forth. Again, easily can interface with these various libraries. We work with minimal overhead here. There's not a ton of Python code to maintain. This work is actually automated to take a user's BART installation and generate from that the respective function signatures and function code needed to run these tools in Python. So for anyone interested in that, the GitHub repo on the MRI Recon GitHub page contains some more information about just how this is automated and how users looking to expand upon BART, maybe locally, can actually automate that code as well, or can automate anything new that they introduce to expose it to Python. And then additionally, this numerous low-level libraries that are very powerful within BART will be exposed by this project to Python developers, meaning that very powerful reconstruction pipelines can be developed using some of the underlying features of BART that are currently inaccessible from the command line. So the current release of the Python interface includes stable generation of functions for command line tools. So anything that a user can currently do in BART from the command line is now also accessible from Python. This is great for writing high-level reconstruction pipelines. Again, anything that you might have worked with BART in the past can still be done with this interface. Additionally, on the GitHub repo, there is some current information about bindings for low-level functions and tools. These are in a highly experimental phase, haven't been completely tested yet, but for users who are interested in getting involved, interested in looking at the development here and helping out with this project, that's a great place to take a look at things and see what direction we're moving in.
Yeah, maybe it's worth adding that one of the things that we're trying to do is make it seamless with development. So basically that it was all generated automatically,
Right.
rather than, so any C code that generated the Python interface would be generated automatically.
Thanks, Mickey. Yeah, absolutely. So a big part of these bindings and this command line tool function signature generation, as Mickey said, is automation. So the command line tools actually are generated using this new interface flag available as of BART version 0.7. And some of the low-level bindings are created with SWIG, Simplified Wrapper Interface Generator, if anyone's familiar. So there are some examples. There's a document folder in the GitHub repo, which I'll show off shortly, which contains some information around that. But very critical to install and run this, one must have the latest stable version of BART, contains this interface flag, which is what we use to generate these function signatures. So again, for any developers in the community who are interested in this project and would like to get involved, we're looking for help on testing the existing code, especially finding ways to automate our testing framework as well. So when something changes in BART, something changes in the Python generation side, we can easily make sure that none of the existing code has broken, as well as helping to move the project forward in developing bindings for internal libraries. So that's using SWIG to create frameworks for automating existing C code within the API. So the GitHub repo, I'll show off in a second, has a developer guide, which documents some of the work that we've done already and additional steps forward for anyone looking to get involved. So with that, we're going to move to a brief tutorial of the installation. Thank you all so much for watching so far. All right. So now All right. So in my browser window here, I have opened up the GitHub page for BART-Pi on the MRI Recon GitHub. This contains all of the necessary code for generating the Python bindings, downloading and installing the toolbox, or any of the further development work that users might be interested in. So we have our README here, which reiterates some of what I just talked about in the presentation, and also gives some information towards future development. So to actually install the tools, it's very straightforward. Just clone the GitHub link. So if we expand here, we just clone the GitHub link to my local machine. And then moving into the folder that I've just installed things to, just downloaded things to, I just need to install it with the command python3 setup.py install. So for anyone in the community who's downloaded existing Python packages from GitHub, this should look very familiar. Depending on your BART installation, you may see a few warnings. That on my end, I've changed a few things, so that's reflecting that. But what this does is both generate the library and then install the Python package automatically. So with that, we've included a few demos in this repo to get users familiar with some high and low level use cases for the Python library, as well as differences between the existing library and the previous wrapper. So I'm going to start one of those demos that illustrates through a parallel imaging example some of the contrast between the existing wrapper and the new Python library. This will also show off a little bit of the integration with NumPy and some other libraries that you all might be familiar with. So to give a brief overview, I'm going to show off here, looking at the GitHub page, we have a demos folder within the repo, in the project structure. So moving into this folder, we have a number of examples ported from existing examples in MATLAB that show off some of the things that can be done with this repo. So moving on my local machine, switching into this demos folder, going to launch some Jupyter notebooks that show off what we're working with. All right. So I'm going to start off with this demo that compares the existing Python wrapper with the new tools library of BART's Python interface. So we've ported this demo from MATLAB. The original examples are available on the MRI Recon GitHub page, the BART page specifically, for anyone who's interested in looking at original MATLAB example. So just a few imports to get started: matplotlib and NumPy, familiar scientific Python tools. So as Mickey mentioned, we are still supporting the original interface. This is available in the original BART installation, but is also included in the current interface under the wrapper module. So from the BART-Pi wrapper, I can import the single function BART, which is the same BART function that users who have used the existing interface are familiar with. So here we have a quick example of loading some data and then a simple FFT reconstruction. The CFL library is also something that was originally included in the BART Python interface to interact with our data format for BART. Oh, that wasn't supposed to. Oh, whoops. Forgot to unzip. Another important part of the installation, these demos all include data that exists within this data zip file. So before you run things, just make sure you unzip and inflate that file to have access to the data that we use in the demo. So a little bit of a live debugging example here. Just going to move everything into the data file. All right, with that, we should be good to go. All right. So just to give a brief rundown of this code and how things work in the existing BART interface. First, we load the data using the CFL library. It contains some very nice tools for reading complex float valued data. Once that data has been unzipped, of course. And then to call a BART command, we pass to this function BART number of output arguments, the command string. So that includes the name of the command, any existing flags that a user might wish to pass to the command line function, as well as additional numerical arguments and arguments to said flags. So for example, performing a root sum of squares calculation on BART from the command line, I would pass in the bit mask specifying the dimension on which I would like to perform this calculation. Here, that's dimension 3. So I pass that in as an argument to my RSS function, or RSS command, RSS tool. And then I specify the data file that I'd like to work on. So this is how things have been done with BART on Python, with BART in Python for a little while now. So we can see performing an inverse FFT. We specify all of our flags here as well. And essentially what's happening is we're calling these functions from the command line just within Python. And this requires users to be very familiar with the command line interface for BART, as well as some of these conventions like specifying the number of output arguments that might seem a bit unfamiliar to those who are totally used to a Python interface. So with that, we see though that our results look wonderful, exactly as we intended and would expect things to come out. So the functionality within Python is preserved. Now the new interface preserves the same functionality, but does things in a bit more of a Pythonic way. So instead of using a single BART function, we now use the various help strings and interface documentation within BART to auto-generate Python functions for these command line interface tools. Additionally, we've ported things like the CFL module right into this BART.py library. So everything you need to interact with BART in Python all exists within this structure of Python modules. So to get started here, we're going to import the tools library. BART.py.tools contains all of the command line tools that you're familiar with if you've worked with BART in the past, whether it's through the existing Python wrapper or on the command line. Additionally, BART.py.utils is a module that contains CFL interface for which with which we can interact with complex float valued data files and anything that BART might generate. So again, let's run through that previous example just to show that functionality has been preserved. Going to load the data with the CFL library. Wonderful. And to get a sense for how these tools are generated, how these functions are generated, we're going to take a look at the existing help string for PIX, parallel imaging and compressed sensing function in Python or in BART, and show how it's translated to Python. So we see here, there's an extensive set of command line flags, input output options, all sorts of various flags to call from the command line. Now, we take this entire string and parse it to generate Python code. So to get a sense for what that looks like, I'm going to run this help command on the PIX function in the Python interface, which will show us all of the options that are made available. So you can see that these inputs have been rendered positional arguments in Python. So now, instead of having to pass these in as we did in the previous Python interface as a set of arguments alongside the number of arguments and command line strings, they're now available right off the bat as positional Python arguments. And then each command line flag is now specified as a keyword argument in Python. Additionally, for some of these flags, which may have a single letter name, we've parsed out the docstring to give some further documentation as to what these flags do, to give users a full picture of the tools they're working with and make it very seamless to pick up BART right within Python. So again, the use of this library doesn't necessarily require existing familiarity with BART. Documentation and function signatures should provide users with enough information that if need be, they can get started right within Python. Additionally, if a user is experimenting with their own BART installation, whether that's adding a new option or an entirely new tool, as long as that is exposed to the interface flag in BART and has a well-written help string, that tool will be parsed by the Python script as well, making it very easy to develop something in C and then work with it right in Python. So we're just going to reproduce the previous example, the zero-filled sum of squares, root sum of squares reconstruction. So now to demonstrate equivalent functionality, you can see I've run the same tools here, but for example, in the case of root sum of squares, instead of passing in RSS with the bit mask as a string to the BART function, it's an existing function within the Python tools module. We pass in our bit mask as an argument to the function. For our FFT, now we have a nice FFT function. We can call the inverse flag as a nice keyword argument. You see, we run these commands, get some nice NumPy arrays, and then plot these nicely to see that the functionality between the new Python interface, the existing one, are equivalent. So the functionality here is totally preserved. The difference is that now everything is accessible in a very Pythonic manner. Additionally, things that may have been difficult in the past, like passing in sort of multiple arrays as an input, are rendered possible in the Python interface. So I'll show something involving that in a little bit.
Should we
Now,
stop real quick to see if
yeah,
there are
sure.
any questions?
Sure.
And feel free to unmute yourself if you have questions or use the chat. And maybe you can scroll up a little bit just to show on your screen the actual interface.
Absolutely.
Yeah. Mm-hmm. Any questions? All right, there is a question in the chat. Is this new interface usable in Windows?
I don't believe we've tested things in Windows yet. I think that's an area of development that we're actually looking to get some testing available in. So if any users are interested in trying it out and seeing what works and what doesn't, that would be really cool. I know the existing interface had some separate catches for WSL support, I believe. So that's something that is definitely possible to be implemented if the existing interface is breaking in Windows. And that's a direction I think we'd love to take things because we have a good amount of Windows users in the community.
Yeah, and I think that there's no real technical hurdle that needs to be overcome. And maybe it's something that we need to include, and it would be helpful to have some as testers. There's another question in the chat. It's a little bit more involved. It's about using a particular function called FFT and then using the bitmask tool. But Cornelius is saying that it doesn't seem like it's doing the right thing. Is that something you can test out for us live? Even?
Yeah, sure, we can see. And if we run into a bug, maybe that will be something to fix after this. So yeah, let's start with just showing off the help string for the bitmask tool. Whoops, tools. Yeah, so, right, so this tool expects the dimension as a tuple. So pass in the necessary or the required dimension that we'd like to see. And then we can get the bitmask from, or the dimensions from a bitmask by calling this -b parameter, which returns, instead of a necessary bitmask, takes a bitmask and returns the desired dimension. So in the case here, that tuple is dimension 3, which I believe we should expect to see a bitmask of value 8. Let's see what happens. Oh, that's interesting. Okay, it looks like the return string is actually broken there. So that should return an integer value. And I'm going to take a look into the code base afterwards to see what's gone wrong there. I changed a few things debugging over the past week, so something might have missed me there. But thank you for that catch, Cornelius. Much appreciated.
Next, can you try like without passing the array? Like just pass.
Oh, for sure. Yeah. Yeah. So it expects the. Yeah, it expects the array, because if we wanted to do something like this, we would want that to.
You know, it looks like what's happening on the left in your Jupyter notebook is showing the entry, so it's going to standard out instead of being caught by the return.
Oh, right. There were a few other things that popped up with that too. Yeah, so that's an issue with redirecting the output from the terminal to an actual value to be parsed. So that's a great catch, because that affects a few commands. Cool. All right, well, that will be first order of debugging then. Thank you for that catch, Cornelius.
Any other questions? And you know, again, we're happy for you to break the code. That's one of the purposes of this webinar, to help us see what's missing. All right.
Awesome. Thank you, everyone. So we've shown that the functionality seems to be largely identical. So we're going to move forward to look at how we can integrate this library with some of our other familiar scientific Python libraries. So first, we're going to create a calibration matrix for our undersampled data. Briefly, in some of these examples, we've shown what the command looks like in the existing Python interface and how things look with the current interface. So this is a nice way of comparing things and getting familiar with some of the new Python conventions that we're working with here. So we're going to create the calibration matrix and then perform SVD on that matrix using NumPy's SVD function. So briefly taking a look at the data type of the calibration matrix, we're working with complex float valued numbers. So that's preserved from BART to NumPy. And now if we do a nice plot of the singular values, things sort of decay as expected. So now we're going to call the eCalib tool. This shows a nice example of returning various functions that return multiple arrays in BART and how that is seamlessly integrated as returning multiple Python NumPy return values, in this case, specifically NumPy arrays. So in the existing interface, we would specify our 2 output arguments, BART command, then call eCalib with various flags, and then that one actually, and then pass in our input array. Here, that same functionality is preserved, but we no longer need to specify the 2 output arguments. Here, when the tool is parsed out, when the BART interface is parsed to create this function signature, we can see from various attributes of the interface that we're expecting 2 return arguments here, and we're going to just grab the maps from this function. So we've run our eCalib tool. Now we can see in the Jupyter Notebook window that from the standard output from BART is available here. As the last bug demonstrated, the next iteration, the next push to this GitHub repo will actually push the standard output to the command line, and where it's necessary to be returned as a value, that will be returned on the command line. But we can see that eCalib has been performed. We're going to grab the first set of maps here. So we're going to use our familiar Python NumPy indexing, using the ellipses to grab everything up to that last dimension, then grabbing just the first set there. And now we see we have our large array. And once we've performed our squeeze command and grabbed the first set of maps, everything dimensionally works out as expected. So from previous Python examples, we have a quick technique for plotting our maps, and we're gonna lay those out. So again, the very sophisticated matplotlib interface lends itself nicely here. Created some pretty and informative plots of various of these maps, and then sort of intensities and phase. And again, we can just check to confirm as we move along what the various shapes of our arrays are, confirm that everything going as expected. So now we're going to do a pretty powerful reconstruction using the PIX tool. For anyone curious about learning more in depth as to what PIX does, we have shown that in some previous webinars. So definitely recommend, it's a very powerful and sophisticated tool. So we're going to perform our recon by passing in both the sensitivity maps and the undersampled data. And we can see in standard output the same information that some of the same information that BART would give is available here. Shape checks out. Plotting our reconstruction we see we have this beautiful image. So before we move on to just briefly show off where some of the other demos are available and give a little look at some of the more advanced features here, does anyone have any questions? All right. If there are no questions, we have a little bit more time. So I'm going to show off a nice non-Cartesian example, which gives some more examples of how some of the sophisticated features of BART, like the non-uniform FFT implementation, are easily accessible in Python, as well as showing how the new interface makes it easy to interact with functions with multiple inputs, multiple array inputs, some of which may appear in the form of a command line flag. So again, we've ported this demo from MATLAB, the original demo linked here, in case users would like to compare some of our interface options. And we're going to perform our inputs. Again, importing our BART-Tools library as BART. That will expose all of the existing tools from the command line. And we'll grab matplotlib to show off some of our nice results. So first, we're going to generate a radial trajectory using the BART trajectory command. And we can see we can specify our desired command line options. Now we're going to scale said trajectory. And then we'll simulate a phantom with said trajectory. So to note, in the previous interface, this gets a bit tricky. Users have to do something like this, where if I wanted to write this in the previous BART trajectory, or BART interface, I have to be very careful about the order of my arguments. I'd specify my single output, and then I'd have to specify phantom with 8 channels, and then to specify that I'd like to pass in this radial trajectory as an argument, I would have to be sure to include this -t flag as the last argument in the command string, then pass in my desired arguments. And so for the case of something like phantom, it's a bit tricky, but not too bad for those who are familiar with the command. But for some of our more involved commands that require multiple arrays as command line flags, you can see this gets a bit tricky to deal with. One can write the CFL file ahead of time and work with that somehow, but the new interface makes things much simpler by exposing all of those array arguments as command line flags. So we see that we can run everything, generated a lovely phantom. Now we'll scale our trajectory again and use the NUFFT to perform some inverse gridding. So again, we're going to see some nice input or some nice output in our console. And also, just taking note, we've enabled our inverse flag, trajectory flags, all nicely from the command line. Right. Now we're going to perform root sum of squares along dimension 3. We see our image shape is as expected. Now we can plot our reconstruction, see that things look nice, but we have a little bit of gridding here, or a little bit of ringing here. So we'd like to try some more sophisticated options. So,
Next, sorry to interrupt in the
for
middle.
sure.
There's a bit of a tangential question about using the dash interface option.
Oh, interesting. I see.
With
Okay.
0.7. Is that something that is in 0.7 or is it a slightly later version?
I think if Christian's still here, I think he can probably comment best on that. Oh, works when I clone. Yeah. Okay. I think that's the key there is it actually has to be cloned from master for BART. So I'll change that in the slides and upload them, or when they're uploaded to GitHub. But for anyone who's watching, you have to clone BART from GitHub because I believe it's the latest push to master along version 0.7 that contains that interface flag. I think when we were debugging, actually the same issue came up.
So in other words, 0.7, that release may not have this option yet, but a later commit did. So then
Yeah,
we'll be able to write explicitly which version is needed. It looks like it'll be in the next full release. So you do need to use a later commit in the meantime.
Awesome. Thanks everyone. Thank you for catching that, Rob. Much appreciated. Right. So we're gonna try a more sophisticated example now. So again, if I take a brief look at the options afforded by NUFFT, we can specify some dimensions along with our various inverse NUFFT options. So like toplets embedding, preconditioning, things like that to do a more sophisticated recon. So that's something that I'm going to use some of these options now. So I passed in vector of dimensions as well for this NUFFT along with my previous options. And then going to perform unitary FFT along this low resolution image. We're going to work from there. So now we have our zero padded K-space, which we get by resizing our low res K-space. So just to get a sense for what these options are doing, I do help resize. So the dimensions and the sizes here are something that we call multi-tuples, meaning that they're our familiar tuples. So these passing in these iterables, but when this function is called from the command line, it expects those values to alternate. So for BART users, it might be familiar with this syntax. So we expect our resize function to take dimension and then the size along that dimension for each dimension that we're looking to resize here. In the Python interface, we pass in arrays that correspond to one another. So in the case of resizing this low-res K-space, we want to resize dimension 0, dimension 1, and then we pass in the respective side size, as well as our C flag to center that resizing. So again, let's grab our sensitivities from eCalib. This time we've specified with the M flag that we'd like to just keep the first set of maps. Let's take a look at our shape. Awesome, we have our X, Y, and Z dimensions, as well as our set of 8 channels. The dimensions are the familiar BART dimensions, which are described in depth in BART's README, or BART's documentation folder, one of the two, are preserved here in the Python interface. So that should be seamless for users moving back and forth. We have our lovely array. And now we're going to perform more involved PIX reconstruction than the previous example. So as users can see, various informative outputs are available in the command line. Again, check out our Pix tutorial for more information on this command. But now we can see through our plotting our reconstruction, we have a much nicer output. So there are various other demos that users can check out for some examples of high-level reconstruction pipelines. And there are additionally in this repo various developer resources for those who are interested in taking the project farther. So with the last couple of minutes, I just briefly want to point anyone interested to the doc folder and the root of the repo, particularly this swig development markdown file. So we're looking to move into developing low-level bindings, as well as the existing high-level command line tools. As these demos have illustrated, there are a number of the functionality is largely there for most of these commands. We're still ironing out a few bugs, as we saw with the bitmask example. But the next step for this project will be exposing to Python some of the lower level libraries within BART. So while most of this is largely unstable right now, so not complete enough to show off in a webinar setting, there are some files and some interface files available in this Python repo. And there's a developer guide that's included as well for anyone interested in getting started working on some of these libraries in Swig, our interface generator, or not our interface generator, but the interface generator that we've been using. So briefly, this gives an overview of the low-level libraries in BART, how to get started writing an interface file in Swig, which is automatically parses C functions to create equivalent Python functions. We have some examples that are very similar to BART code, as well as examples how to incorporate NumPy. So some very important Swig concepts to writing this code. And some very useful information for creating, so auto-generating these Python files, and then actually installing these files in a Python module, particularly here as it pertains to BART. So we also have a list that I've been compiling of some existing sort of challenges, bugs, things that we're working on. Contains some useful links to Swig documentation. So for users who are interested in getting involved, this would be a great place to start. So I'm going to stop sharing now with our last few minutes. Does anyone have any additional questions?
So Max, that was showing the interface for the tools. Do you want to say just a few words about what is planned for the lower level API?
Yeah, for sure. So there are there's a wide range of tools that are available in the lower level API. So we have everything from these linear operator objects that make a lot of the operations in BART possible in a very useful direction, and one that I've worked on for a bit has been exposing those to Python. So that's a very like general interface for any sort of linear operator, and being able to interact with those objects would be very useful from a development perspective. So that sort of allows us to build on something foundational to how these BART tools work. But additionally, things like their various iterative optimization algorithms implemented in BART. There's some existing interface files to expose some of those as well. That's something else that's very useful in a general sense. But various like reconstruction specific tools like FFTs, NUFFTs are also available in the lower level API, maybe with some sort of different levels of abstraction than the command line tools. So exposing that as well could be very useful to users looking to build and expand upon those algorithms in ways that they might not be able to from the command line tools. So a big goal is just making it very easy for users to take advantage of the powerful tools within BART to develop and prototype more involved reconstruction tools in conjunction with things that are available in Python and various tools there.
All right. Any questions? We'll take questions, then we'll do a quick break before the next part. All right, before the break, I'll just go ahead and share screen just to give you an idea of what we're going to do next. I have here can everyone see my screen with GitHub? Yeah. All right, I have here the webinar directory, the webinar repo. So under BART webinars, I've gone down to webinar5. And Max was just presenting the material under BART-Pi. For the next part, we're going to do these hands-on exercise, where again, we have an exercise without the code the code needs to be written, and we'll be doing that kind of guiding users through it using the new interface, and then also the solution. Now, you can run the notebook locally, or you could also run it through Binder. If you click the Binder tab, then it will open up here the exercise. An important thing to mention is that when you do the exercise, you will need to install BART-Pi within Binder. So if I uncomment this line and run it, then BART-Pi will be installed, and then I'll be able to actually call the BART-Pi tool. So we'll show that off after the break, and we'll go into breakout rooms for that part. And again, you can find all of this under the webinar folder and run it locally or through Binder.